This is coal. Coal which will be burned at an electric power plant. But how do we use coal to make electricity? This program will help you understand the importance of coal. Not only how it is used to make electricity, but how we mine it and how it gets to the power plant. First, let's examine where coal comes from. Coal is actually what remains of plants which thrived millions of years ago. Plants and marshlands grew in great abundance, absorbing energy from the sun. Over long periods of time, floods, volcanic eruptions, and other changes in the earth occurred, and new layers covered the swamps and marshlands many times. Each new layer added tremendous pressure on the layers below. After many millions of years, this pressure changed the form of each layer. What once had been trees, plants, and marshlands turned into coal. This is why coal is sometimes referred to as a fossil fuel. There are many different layers and types of rock above and below the layer of coal. Sandstone, limestone, shale, clay, and other rocks. A layer of coal underground is called a coal seam. The coal seam can be deep below the Earth's surface or relatively close to the top. When it is near the surface and the rocks and earth above the seam can be easily removed, a surface mine can be developed. A surface mining operation is designed to remove the coal and then to restore the land to approximately its original shape. In surface mining, the land must first be cleared. All available timber is harvested. The big trees are used for lumber, and the smaller trees are used for making paper or carton products. Next, the topsoil is removed and stored. The topsoil will be used later for reclamation, after the mining is complete. The area to be mined is then blasted to break up the earth and rock above the coal seam. Now, this earth and rock, called overburden, can be removed. The overburden is removed by machines called drag lines. The drag lines dig down and expose the coal seam. This drag line is called Big Muskie and is the largest of its kind in the world. The big machines remove the overburden, and these smaller machines dig out the coal and load it into large trucks, which haul it out of the pit. After the coal is removed, the area is filled in, smoothed out, and the topsoil is replaced. Grass seed or types of crops are planted. Years ago, this company dedicated some 30,000 acres of reclaimed land as a park area. There are campsites and plenty of lakes and ponds stocked with fish. It's hard to believe, but this area, known as recreation land, was once an active surface mine. When a coal seam is too far underground to economically remove the overburden, a deep mine or underground mine is developed. There are several types of underground mines. When the coal seam is below the surface, a combination shaft and slope mine may be developed. Miners ride an elevator down to the coal seam. Sloped conveyors carry the coal to the surface.
Sometimes the coal seam is exposed at the base of a hill. The mine is developed by tunneling into the coal seam, and this is called a drift mine. At drift mines, coal miners enter on jeeps like this one. The tracks go into an entrance called a portal and up to the face or the working section of the mine, which may be several miles inside. The coal comes out of the mine on conveyor belts.
One method of mining underground is called room and pillar mining. First, the coal is cut from the face by a continuous miner. The continuous miner has a rotating cutting drum that mines the coal. Gathering arms scoop up the coal from the mine floor and transfer it to the back of the machine. The coal is cut, scooped up, and loaded in one continuous operation. Next, the loaded shuttle car transfers the coal from the face to a loadout point. Where it is carried out of the mine by conveyor belts. There are usually 2 shuttle cars working with each continuous miner. After an area has been mined, the top or roof must be secured to prevent it from falling. This machine, called a roof bolter, puts long, strong bolts into the mine roof. These bolts help hold together the layers of rock above the area where the coal was removed. Next, a white limestone powder is sprayed on the top and sides. This holds down coal dust and helps make the mine safer by reducing the chance of a coal dust explosion. Now the cycle is ready to be repeated, and the continuous miner is moved back in. In this mine, the miner operator stays safely back, using remote controls. This process is repeated in several rooms, which are joined together as the mining continues. Large blocks or pillars of coal are left for support. That's why it's called room and pillar mining. Another underground method is called longwall mining. Rather than leaving pillars of coal, longwall mining removes large sections or panels while mining from a long wall of coal. The cutting drum, called a shearer, moves back and forth along a long wall of coal up to 900 feet long. As the coal is cut, it falls onto a chain conveyor, which takes it to a conveyor belt and then out of the mine. The coal miners operating the machine work safely under the protection of these hydraulically operated supports called shields. As the shearer moves forward into the coal seam, the shields and the chain conveyor are also moved forward. The rock is permitted to fall behind the shields.
As the coal comes out of the mine, it is sent into a coal preparation plant. These plants prepare the coal for burning at the power plant. Assisted by computer, these plants lower the ash and sulfur content while raising the heat value of the coal. After the coal goes through the preparation plant, it is ready to be moved to the power plant. There are many ways to transport the coal.
When the coal mine is located close to the power plant, an overland conveyor system can transport the coal. For greater distances, the coal can be moved by railroad. At the mine site, rail cars are loaded with 100 tons of coal each for their trip to the power plant. Some trains have as many as 100 cars. Another way to transport the coal is on the river. One jumbo barge can carry as much as 1,500 tons. A complete tow, like this one, can carry more than 22,500 tons of coal. When the coal arrives at the power plant, it is unloaded and stockpiled until the plant is ready to burn it. The coal goes into the plant where it is crushed and ground into very fine powder, like baby powder. Then the coal powder is blown into a very large coal furnace called a boiler. This boiler stands over 200 feet high. That's as tall as the Statue of Liberty. As the coal powder burns, the temperature inside the boiler rises tremendously, sometimes as hot as 3,100 degrees Fahrenheit. Inside, all along the sides and top of the boiler, are miles of small pipes. As water is pumped through these pipes, the fire heats the water and turns it into steam. The steam goes into large machines called turbines. The steam pressure causes the turbines to spin very fast. The turbines turn a large magnet inside a large coil of wire. This is called a generator, and this creates electricity. The electricity passes through transformers and then through long transmission lines to be distributed to homes and businesses.
After the steam goes through the turbines, it is cooled down and recycled as water. This large round structure behind me is called a cooling tower. Using a natural draft of cool air, the steam is turned back into water. At the top, you can see a cloud of water vapor. The water vapor is from the steam as it is cooled. Here at the bottom, you can see the water after it condenses, ready to be used again. Since coal is used to help make electricity, it is very important to us to make sure that the electricity is there when we flip a switch to turn on a light or a television set, or for use in a factory or a store. We need coal to continue to provide reliable electric energy for future generations.
At present levels of use, there is enough coal to last about 200 years. Coal is our most abundant natural resource. Equally important, though, are the people who mine it and get it to the power plants. Thousands of men and women work in coal mines, and many more work hard every day to move the coal to the power plants. There are also technicians and other workers at the power plant working to produce the electricity.
Just think about all the people responsible for producing the electricity we use every day. It's a tremendous job. And think about our most abundant natural energy source that helps produce electricity: coal.